Welcome back to the lab, folks. So today what I'm going to do is going to continue on with our analysis of these batteries, these little rechargeable 9-volt cells. So I put all four of them up on the load and ran them down until they stopped. And the first one is 481 milliamp hours. Second one, which is this one, is 434. 493, 472 for a total of 1880. Divide that before, we get an average of 470 milliamp hours. Like I'd already mentioned in a previous video, that's right in around what you'd expect for a decent alkaline cell. And these cost just over $6 a piece. A decent alkaline cells costs between $3 and $4. You know, if you buy a Duracell and a package of 4, you're paying around about $3 or $4 here in Canada per cell, and they won't give you any more than that. And another thing I've noticed is that these maintain their voltage, so they're almost precisely 9 volts, and they maintain that voltage all the way until the second they cut out. So you won't get that with an alkaline cell. The alkaline cell's voltage will drop and drop and drop and drop and drop, and once you get about 470 milliamp hours out of it, it's down around about 7.5, 7.8 volts, something like that. And quite likely the equipment that you're using will stop working before that, so you end up with a battery that you can't even use all you can. So these have got great advantages, especially if you can charge them more than twice. Like if you can charge them more than twice and get reasonably close to this amp hour rating out of them, you're way ahead of the race, right? You've got a much more stable supply. So today I'm going to tear one apart. I'm going to look inside it, and then I'm also going to put it on load. Now, I got a great deal of feedback from the first video I did featuring these, and there's a lot of good information there. So I'm going to put them under load to see what kind of noise they produce, because likely what they are is one or two cells in there with a boost converter, and that's why they maintain that good voltage across their entire capacity. And so we'll have a look at that too. And before we get on with that, I just wanted to update you on these batteries here that I got out of the Lenovo battery pack. These ones are rated for 200 milliamp hours, but I haven't been able to get that out of them. Now, I think the best one I got is this one here. Now we can see here it got 1.657 amp hours, or 1657 milliamp hours. That's pretty good. That's going to give me about 6.6 hours of runtime with my light that I have. This one here that I repaired the other day. And that's awesome. That'll be really good. That'll more than what I need. And now let's get on to this. So, okay, we're going to see if we can actually get into this. I'm hoping it's going to be a non-destructive exercise. So we'll just cut along the... See if we can lift that up and get in there. Is it glued on? No, I don't think it's glued on. It seems to be lifting fine. Yeah. I don't care about the shrink wrap as long as the battery is reusable. Yeah, that looks like there's some sort of line here. I'm gonna get a spudger to see if I can get into this. Just a second. I think this should do it. Let's probe around here, see what we get. Yeah, it's lifting. Oh, that's popping right off. Nice. Oh, yep, that's pretty good. Looks like it should be non-destructive, I'm hoping. All right, so here we have, we got a single cell and a little board. A little battery management board there. Let me clean up some of this stuff here. See what the voltage of the cell is. Now this one I had recharges. This is the one that had the lower voltage and the lower amp hour rating. So it's 4.24. That's a pretty well charged cell right there. And then on the output, we're getting 9.146. Okay. I wonder if there's any markings on the cell at all. I can't see underneath there, so let's see if we can take that off. Right off. There we go. Peel this back. Spudger might come in handy for this again to get that. It looks like it's sponge tape in there, so I'm going to wedge this in the best I can. Okay. There's no markings on this side. I know there's a little bit of glue there, but I could pretty well see through that. I can see this edge here through it, so I don't see any markings at all on the battery. I guess we could try taking the foil off it, see what's under there. But I think that would be encroaching upon destructive mode. Anyway, they clearly don't have 1300 milliamp hours. The average being 470. I wonder what that chip there is. So this is indeed, it's an LR5112 from Lori Manufacturing, and it's a battery management chip. And it can be set up for a wide range of inputs and outputs. Input voltage from -5 to 10 volts, output voltage up to 30 volts. And various battery dropout voltages it can be programmed into it. So I imagine it's programmed to drop out around about 2.9 volts or 2.8 volts. So yeah, that would be just about perfect for these cells. So okay, let me put this sort of back together again, and we'll put a load on it and see what the noise is like. I'll get the scope set up there and have a look. And hopefully this goes back together nicely. No nightmares. I'm sure it will. It's just a little. There we go. Fit it back into the case here. Okay, no issues so far. All back together. It's kind of like a press fit. There's no click. I'll probably put a little piece of tape around it. One second, let me do that. Okay, we should have our scope up here, and we have our battery, we have our test clip, we have our probe. I'm just going to hook it up here. We can see what the ambient noise is, about 20 millivolts. So it's not going to make much difference if we already know that. Let's see, then we'll put this on here. I'm picking up a lot of noise myself. I'll put the battery back down. Okay, now that goes up to about, what are we averaging there? About 40 millivolts. Let me see, put statistics on here, see if we can get an average. Yeah, so the average is about 40 millivolts of noise, and that's at 12 milliamp load. So let's see if we can double that load. I'm gonna go get another resistor. We'll get up to 24 milliamps, and 24 milliamps is a pretty heavy load for a 9-volt battery. Most good equipment won't load a battery like that. Okay, so putting that second resistor on there has afforded me a much better way to attach my scope probe. So we're still getting, we're down to about 12 millivolts, they're about 12, 13 millivolts. Let's get a new average here. Yeah, so around about 12 millivolts average on the peak-to-peak noise, which is the way it's set up here right now. Now, ideally, I would like to have the probe down here, but I'm not going to be able to arrange that in any reasonable manner. So let's now hook this up here and get my hands out of the way. All right, so that is much better. That's a much better measurement. Now we're putting 24 milliamps through those resistors, and we're getting get an average here about 19 millivolts of noise. I think that's pretty good. I think we're doing all right here. Is there any way to get that to trigger on there? Is there anything really I could trigger on? Yeah, it's just noise. I think most of it is just picking up from the environment. So I think these boost converters here are pretty quiet. They're doing a pretty good job. Now I could put a much lower resistance on there, but I don't think that's really necessary. 24 milliamps could be considered a fairly high load for a 9-volt battery. So for typical usage, you're going to be around about 10 milliamps. So this is actually pretty good here. So we're leveling out here an average of 17.49 millivolts noise. I think these batteries here are pretty good value, despite not meeting their 1300 milliamp hours by a factor of 3. They're well worth the money, especially if you can recharge them 4, 5, 6 times. You're going to save a fortune. You're going to keep a lot of crap out of the landfill. All right, folks. Well, thanks for joining me today. I really appreciate it. Hope you got something out of this, and I'll leave a link to these batteries down in the description in case you wanted to try them out for yourself. We'll see you later. Bye bye.